events are independent, or how to answer a question, whether they ask us whether events are independent, because the setting out of that is really important. Okay, so let's jump into our first question. It says that a school organized a camp for their 103 grade 12 learners. The learners were asked to indicate their meal preference for the camp. They had to choose from chicken, vegetables, and fish. So the following information was collected. 2 learners do not eat chicken, fish, or vegetables. 5 learners eat vegetables only. 2 learners eat only chicken. 21 learners do not eat fish. 3 learners eat only fish. 66 learners eat both chicken and fish. 75 eat both vegetables and fish, and X learners eat all 3 options. They want us to redraw the Venn diagram and fill in the information. Okay, so before we start filling in the information, I want us to just discuss very briefly what the different regions of the Venn diagram represent. Okay, so the first thing that I'm going to do is highlight this section over here. So the section that I've highlighted in yellow, what does that represent? What does that mean? How would I describe the yellow region using words? Okay, good. So some nice answers coming through. Zakira, students who eat all 3. iPhone 2, they like vegetables, chicken, and fish. Good, well done. Okay, so would I use the word or? Would I use the word or to describe the yellow region? Would I say vegetables or chicken or fish? Or would I say vegetables and chicken and fish? What would be the correct way of saying it? And good, well done. Okay, so vegetables and chicken and fish. They eat all 3 options. Excellent, well done. Now, what if I took a different highlighter and now I highlight this region? So now I'm including the yellow in this. What would this be? How would I describe this region that I have colored in pink? Oh no, that looks orange. How would I describe that region? So now like this. What would this be called in words? Lesejo says veg and chicken. Good. Okay, so the pink region is veg and chicken. Okay, some of them also eat fish, but the pink region is veg and chicken. Now, if I get rid of the pink and I just highlight this area over here, the blue part, how would I describe that part? How would I describe the turquoise bit? Good, Katleho. Good, Lihlu. Nice, iPhone. Good, Kamogelo. Perfect. So veg and chicken only, or veg and chicken but not fish would be another way to describe that blue region over there. How would I describe this region over here? So the one with the pink lines in it. How would I describe that? Chicken only. Good, well done. So that would be chicken only. Okay, those that eat chicken only. And what would happen to people that do not eat chicken or fish or vegetables? Where would their information go? Okay, so outside the There we go, iPhone 2. In the box, but not in the circles. That's it. So in the box, but not inside the circles, not inside the events. Okay, well done. So you guys understand the different regions, which is really important to be able to answer these questions. The first thing that they want us to do is redraw the Venn diagram and fill in the information. I think what I'm going to do with you guys is let you do that by yourselves. Do you think you can do that on your own without me? Do you want to try it on your own? You feel confident to do that? Okay, I've got one thumbs up. Okay, so draw a Venn diagram for yourself. I'll make this information just a little bit bigger so that you can see it okay. There we go. I'll just move it down. And you guys, I'll do it there. There we go. Awesome. Okay, so you try this question and let's see how it goes.
Let's remember to stay muted.
So they're drawing this on their own, Yolanda.
Oh, nice.
Yes.
Oh, we can't take the picture again on the other side, or can they see everything?
Well, it's a little bit cut off at the bottom over here, but they know that there's fish down there.
Okay,
so they're redrawing that, and then they're gonna
fill in
the Venn diagram. Absolutely.
Nice.
Yeah. Yes, Lesejo, there will still be classes when you're writing trials. So Watobe does lessons the whole way through the year, right up until the last lesson that we would do. You will always write maths on a Friday, Monday. Normally maths is the first weekend when you start your exams. English is always your first paper. And then the first weekend you normally write maths. So we will do lessons right up until that Saturday between the papers. So on that Saturday, we would only do paper 2 work. We wouldn't do any paper 1 work because you've written paper 1, and then that'll be it. Okay, and then you're free. All right, when you're finished, I don't want you to share your answers on screen because I don't want to disadvantage anybody. But if you can just send me a note to say that you're done, then we've got an idea of where you're at. If you want to, if you're finished, you're welcome to look at the next set of questions. Okay, so these questions come after drawing the Venn diagram. Okay, oh, so there are a bunch of you that are done already. Okay, cool. So those people that are done, you try the questions and we'll just give the others a chance. Cool. You're struggling with it, Kamogelo. I'm sorry. Okay, we're going to go through it together, I promise. I'm glad I revised this with you, and I hope once we go through it, it'll be a little bit easier for you. Okay, so Kamogelo, thank you for your honesty. I so appreciate it. And it's no problem at all. Okay. I don't know if I've given you guys enough time. Can I start going through the answers? Is that okay? Yes, we ready? Okay, cool. Right. So the best way to approach these questions, in fact, the only way to approach these questions, is that when they give you all the information that has been collected, go through everything until you find where it says they eat all three. That is the very last one, which in this case, they have called X. You must fill that in first. So what I'm going to do is I'm going to put X in the center. So now it's not always going to be X that goes in the center. The X could actually go anywhere. But in this particular example, X is the one that goes in the middle there because this is all three. Then what I like to do is cross that out. I know that's a little bit more difficult for you guys because you don't have this in black and white in front of you. I think that would always be easier. So put that in first. Now go and look for the words and. Okay, so chicken and fish, or vegetables and chicken, or vegetables and fish. Okay, so if we go here, 66 eat both chicken and fish. So 66 eat chicken and fish. So chicken and fish is this bit over here. So chicken and fish only is going to be 66 minus X. Does that make sense to everybody? Is everybody clear on why I've written 66 minus X there? Okay, so lots of yeses coming through. All right, brilliant. Now go and look for another and. Okay, so 75 eat both vegetables and fish. So 75 eat vegetables and fish. So vegetables and fish, matrix. Vegetables and fish is this bit over here. So vegetables and fish only is going to be 75 minus x. That will be that little piece over there. And again, go and cross that out. Okay. Now go up. All right. And let's go and see if we can maybe fill in this region, chicken and vegetables. Right. So above here, we see 3 learners eat only fish. Only fish. 3 learners eat only fish. So that means we can cross that out and we will put the 3 over there because that is fish only. Okay, so now we've got that one. Then they tell us that 2 learners eat only chicken. 2 learners eat only chicken, so that 2 will go over here. As far as the vegetables are concerned, 5 learners only vegetables. So that 5 would be over here. Then they say to us, 2 learners do not eat chicken, fish, or vegetables. 2 learners do not eat chicken, fish, or vegetables. So that 2 has got to go on the outside. And the last piece of information that we have here is 21 learners do not eat fish. 21 learners do not eat fish. So if you do not eat fish, it means that, and I'm going to highlight it for you here, this part over here. So what I'm highlighting in yellow, everything inside the yellow border are the people that do not eat fish, including these 2 people out here, because they also do not eat fish. Does that make sense to everybody? This is not an easy Venn diagram. Does that make sense? That's an iPhone. So to work out what goes in that piece of intersection over there, it would be 21 minus 5 minus 2 minus 2. Quite right. Okay, so how much is that? 21 minus 9. Okay, so that means that there are 12 people that go in that section over there. Does that make sense to everyone? Okay, so Shisana says yes. Oh, it's a pleasure, Lesejo. This was a difficult question. I didn't give you guys an easy question to start with. Okay. All right. So Iola, which part do you want me to explain again? Yolanda, maybe you can help Iola. If there's anything that I need to explain again, I'm obviously more than happy to do that.
Okay.
Okay, Iola, Yolanda's going to see if she can help you. Oh, the 21 that don't eat fish. Okay, there we go. So it's not everything. Okay. So now, Matrix, so Iola, Yolanda's going to help you directly. And I'm going to talk about 12.2. Is everybody else sure that they understand this? There's no other questions. So now they want us to calculate the value of x, and they want us to show all our working how we got to our answer. Oh, one thing we didn't do is we didn't put in the marks here, okay? So this is out of 3. So there has to be a mark on that 12, because that's something that we would have had to calculate. And then I imagine this was also something we had to work out, and that was also something we had to work out. The 2, the 3, the 5 were given to us, okay, as well as the X in the middle. And this over here on the outside was also given. So we would get the marks on the calculations that we would do. All right, so let's go on to 12.2 now, calculating the value of X. All right, so does anybody know how we calculate X? Can you guys tell me what we should do in this case? If anyone wants to unmute and speak, you're welcome. How would we calculate the value of X now, guys? Okay, equate everything to 103, form an equation, add all the values and make it equal to 103. Perfect. Okay, lovely. Shoshana, perfect. Okay, so add everything together and make it equal to 103. Beautiful, Hendrina. Add all the variables and equal to 103. Perfectly put. Okay, so we are going to add together 5 and 12 and 2 and 75 minus X and 66 minus X and 3 and 2. And we're going to scooch over. Oopsie, we're going to scooch over a little bit here. And as you said, we're going to make that equal to 103. So we just need to be super careful that we don't leave out any of our values. So we've got 5, 12, 2, 75 minus X, 66 minus X, our 3, our 2 on the outside, and it equals 103. Okay, so as far as the X's are concerned, we've got minus X plus X, that would add up to 0. So what's left here is a negative X on the left-hand side, which is not a problem. And on the right-hand side, we'd say 103, and then we would minus all those values. What do you guys get? It better be a negative number, otherwise we're in trouble. What are you guys getting? I've done it on my calculator. What are you getting negative X equal to? Okay, so a couple of little differences there. In Bali, I got the same answer as you. Hendrina, my answer was slightly different. Katleho, I was very close. iPhone, yes. Lihlu, yes. Sihawu, did you maybe leave something off? Ntlafatso, even me. Okay, I also got negative 62. So just be very careful, guys. You're saying 103 minus 5 minus 12 minus 2 minus 75 minus 66 minus 3 minus 2. So I get X is equal to 62 in this case. All right, so that means the number of people that eat all three, vegetables and chicken and fish, there are 62 of them. So we can work out the number that eat vegetables and fish only and the number that eat chicken and fish only. All right, so here we've got 62. Here, if we took away 62, there would be 4. Sorry, it's not a very nice way of setting it out. And 75 minus 62 means that there would be 13 in this little green block over here. All right, so now they tell us in 12.3, oh, sorry, marks. So 1 mark for making the equation, and then a mark for the answer. Back to the next question. Calculate the probability that a learner chosen at random eats at least 2 of the given food choices, at least 2. How do we do that? Where would we look for at least 2? Katleho?
Ma'am, don't you calculate the number of learners that eats more than 1, ma'am? Meaning the learners that are between the circles, ma'am. If that makes sense.
It does, and you're on the right track. I mean, it's obviously difficult to describe. Let's have a look. Letu says the parts where the circles are overlapping. Lovely, Letu. That's exactly what Katlego was trying to say as well. Good, beautifully put. The parts where they are overlapping, including where they eat all three. Yes, Letu, good. Well done. So at least 2 means 2 or more. Okay, so it's going to be all your areas of overlap. So probability of at least 2 is going to be the 12, the 13, the 62, and the 4. Does that make sense to everybody? You know where I'm getting these numbers from? The 12, the 13, the 4, and the 62 out of 103. Okay, 91 over 103 says Miss Cindy and iPhone. There we go. All right. Does it make sense to everybody where these numbers come from? The 12 plus the 13 plus the 4 plus the 62. I'm sorry, it's a little bit small. We're all good with that. Okay. I'll take that to mean yes. Okay, thanks, Kamachelo. All right. So if all of that, so Lesejo, did you get, so the equation is here, 5 plus 12 plus 2 plus 75 minus x plus 66 minus x plus 3 plus 2 equals 103. We're adding everything together, everything that's inside the circles, as well as that which was outside the circle. Okay, so you should have got negative 62. 62 is the right answer. So negative x equals negative 62, and then x equals 62. Yes, that's correct. Okay, Lesejo, you didn't get it wrong. I got the same answer as you. Okay, over here, I'll just highlight it in turquoise. Okay. All right. So let's move on and go and have, we can always come back to this. What I'd like for us to do now is to talk about, maybe we can come back and do this at the end of the lesson. What I want to speak about now is independent events and two-way tables. So again, this is something that you would have seen in grade 11. Tables like this are referred to as two-way tables. And we sometimes also refer to them as contingency tables. Although I don't really know why we use the word contingency. To me, the word two-way makes so much more sense. So the results are provided and added in 2 ways. So often it's with gender. And then in this case, it's a final economics examination, and they've said the result either is that you have passed or you have failed, and that you are either male or female. Okay, so the total number of males was 390. The total number of females was 610, so the total number of people was 1,000. The number of people that passed, they were 590, and the number of people that failed, that were 410. These blocks inside here are like an area of intersection. So the 230 over here is male and pass. The 160 over here is male and failed the exam. Okay, so the female, there were 360 females that passed and 250 females that failed the exam. So they give us these tables, and now they're asking us a question. The first question is, are the events pass and fail mutually exclusive? Give a reason for your answer. So what do you think, Matrix? Are the events pass and fail mutually exclusive? What do you think? There we go. iPhone. Yes, they are. Okay, so it's out of 2. So we would have to say yes, they are mutually exclusive. And now we need to provide a reason. So yes, they are mutually exclusive. Okay, and I think the way that, let's see, let's go up here a little bit. iPhone 2, I'm not sure who that is, put it, they cannot happen at the same time. Yes, so it's not possible for you to pass and fail an examination. Okay, so it's not possible to pass and fail an exam. Okay, so it's either the one or the other. Yes, and Kani, so that's a lovely way of putting it. Okay, the probability of passing and failing is equal to 0. Okay, there is no intersection. Maybe that's another way we could put it. Okay, so no intersection of pass and fail. Okay, so I think provided we explained ourselves like that, we would be absolutely fine with our 2 marks there. Okay, let's have a look at what they do ask us. So the first thing they say is calculate the probability that a student selected at random from those who wrote the economics examination is male. So what do you think, Matrix? The probability that the person selected at random is a male, what would we write? What's that probability? There we go. iPhone 2, you quick off the mark there. 390 over 1,000. Okay, or 0, oh, sorry, it's out of 1,000. So 0,39 would be another way of putting it. Yes, perfect. Okay, and that 390 comes from that answer that I've just circled right now. Perfect. The next one says female and passes the exam. So female and passes. What's that? That's at iPhone 2. Well done. Yes, and Kaniso, perfect. Lovely, well done. Yes, Miss Cindy, yes, Katleho. Beautiful. Okay, so you guys are looking at that value over there. Female and passes. Good, well done. Perfect, perfect, perfect. So now, yes, Nondamiso, you got a question? Welcome to unmute and speak.
So, ma'am, if they're asking us like to be gender specific, like if they want the answer 360 over 610, like how would they phrase the question?
So they would have to say female and pass. So they would have to give you this way and this way in the table, okay, because it's both at the same time. So if they said to you, what is the probability that a student selected at random is male and fails, you are going to go across to male and down to fail, and then you're going to read in that block. Okay, so male and fail, making rhymes here, male, and then come down with fail. All right, so that's why it's this block that I'm highlighting in yellow. Does that make sense to you?
No, ma'am, that's not my question.
But you said that if they wanted you to answer a specific question on gender and passing and failing, would they? So here, male and fail, they're going to have to tell you both, yes.
So how it, like, you see, ma'am, the second question, it says female and passes the examination,
Yes.
right?
Yes. Yes.
So I could answer that it's 360 over 610.
No, 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 no. 610 are the number of women.
Mm-hmm.
Okay, so what they say here, that a student selected at random, they mean from the total.
Okay.
Okay, so they don't mean how many, out of how many women, how many females passed. Because if you did 360 out of 610, we are excluding the men and we're only looking at the women. And that's not what the question means. They said that a student selected at random. So they are implying that it's everybody, not just the woman. Okay.
Yeah. Okay.
All
Thank
right.
you.
No problem. All right. Let's see. I think there was somebody else with a question as well. Okay. Sorry. See how I will? Okay. So in a two-way table, let's just talk about this a little bit because this is the second question. All right. If they wanted you to use the sihawu as your denominator, all right, they would have had to say how many of the people that passed, or what is the probability of being what is the probability of passing given, now what is the probability that it is a female that's, or how would we phrase this? Because this would be a conditional. So they would say a female selected at random. Yes, a female selected at random. What is the probability that she passes? Then it would be 360 out of 610. Okay, but that's not what they're asking us. They're saying to us a student selected at random. All right, so that means both the male and female students. Okay, so our denominator would be 1,000. Okay, so again, we've just got to read it very carefully to make sure that we're interpreting it in the way that it is intended. Okay, they generally don't tend to ask questions like that because conditional probability is not part of CAPS. So we don't look at situations where given this, then what is the probability of something else happening? Okay, I hope that answers the question for both of you. All right, let's have a look at the last thing that they ask us. Is passing the final economics examination independent of gender? Justify your answer with relevant calculations. All right. Does anybody have any idea how to answer this question? How would we answer? What would we use to answer our question? We've got to do some calculations. There's a specific formula that they want us to use. Does anybody know what that formula is? And how would we know that they want us to use it? Any ideas here? No, no one? Okay, well then it's a good thing that we're revising this, hey? Oh, there we go, there we go, there we go. Hendrina, perfect. Yes, Miss Cindy. Okay. All right, so if you guys have a look, the answers that have Hendrina and Miss Cindy have put there for us are absolutely perfect. So when events are independent, okay, so I'll just write here for you, when events are independent, we would say the probability of A and B equals the probability of A times the probability of what B is. That's the rule for independent events. Okay. Incidentally, before we continue, what do they mean by the word independent? I mean, when they say, is the final economics exam independent of gender, what does the word independent actually mean for us here? Can anybody explain that? What does the word independent mean? Beautiful, Jude. I wish you told everybody that. That's lovely. Yes, Lisedi, also true. Litlu, beautiful way of putting it. Okay, so both Litlu and Jude have sent me DMs, both with beautiful ways of putting it. Okay, so Jude said, does the gender determine whether they pass or fail? Lovely. Lisedi, not influenced by. Yes, correct, Lisedi. That's what independent means. Litlu, you don't need to be a specific gender to pass. Perfect. Okay. iPhone 2. They happen regardless of the others. Absolutely. So, but it's specific to gender. Okay. So, in other words, is it possible that you being a male influences whether you pass or fail? Does it, being female, does that influence whether you pass or fail? So, think about it like this. All right. Another independent event would be, when your mom had you, she had either a girl or a boy. But if your mom then had another baby, like a younger brother or sister, just because you're a boy doesn't mean that the next baby is going to be a boy. Okay, so the gender of a baby does not depend on the gender of any previous children that are born. Okay, so they're independent events. Okay, so that's another way of looking at it. When events are dependent, we've actually had a look at dependent events. And we did that in our previous lesson when we spoke about the dogs and the cats. Okay, because I don't know if you remember this from our last lesson. So we had said that there were 30 dogs and 25 cats. So if a person chose a dog the first time, they'd have a 30 and 55 chance of choosing a dog. But the second time that you choose a dog, the probability that you'll get a dog is dependent on what the previous probability was, because now there's one less dog and one less pet. Okay, so choosing a dog a second time depends on your first choice. Okay, whether you chose a dog or a cat the first time. And then choosing another dog also depends on your previous choice, because there would be 2 less dogs and 2 less pets. Okay, so these are examples of where things are dependent. So in a tree diagram, we see dependent events coming through where there is non-replacement. Okay, so you can't replace a pet. If you take like a ball in a bag and you take the ball out and you look at it and then you put it back in the bag, then you're not going to have dependent events. But if you look at the ball and you take the ball out, then you are going to have dependent events. Does that make sense to everybody? Understanding the difference between independent and dependent. Okay. Cool, Katleho. Thanks, Shasana. All right, so we cannot assume that the left-hand side equals the right-hand side. Okay, so if this is like almost like an identity where you have to work with both sides. Okay, like a trig identity, but you've got to work with both sides. You cannot write that they are equal. If you write this as your first thing, they're going to mark it wrong. Okay, because everything else will be wrong, because we cannot assume that the left-hand side equals the right-hand side. So we work out probability. And here, again, we're going to make a choice because they just said independent of gender. So going back, you can choose whether you want to look at male and pass, or male and fail, or female and pass, or female and fail. So there are 4 different options you could choose from. What I would say to you is, if you've already got some information, don't go and waste your time recalculating stuff. Use what you've got. So, because Yolenda's a girl and I'm a girl, we're going to go with female and passes the examination. Okay. Also, because we've already got this information. So let's work with let's work with that. So we're going to work with probability of female and passes, which we've all already established is 0.36. Now we're going to separately calculate the probability of being female times the probability of passing. So the probability that a person selected at random is female would be what? No, that's not okay, Pinga, because if the left-hand side does not equal the right-hand side, you can't start off by saying that it does. Okay, so the setting out here, Pinga, is very important. Okay, even if they are equal, you cannot start off saying that they're equal. All right, you've got to do the 2 calculations separately. If they're equal, I'll show you, we would conclude what we see in black. And if they were not equal, then we would put a line through the equal sign. But it's got to be 2 separate calculations. Okay, yes, iPhone, quite right. Okay, so I moved it down. So the probability of being a female is 610 out of 1,000. Yes, lovely. So we're going to put that in here. 610 out of 1,000 multiplied by the probability of passing. What is the probability of passing this economics exam? Yeah, Pinga. Don't make the same mistake again, okay? Yes, 590 out of 1,000. Well done. Right. And what often helps with these sorts of calculations, matrix, is round your answer to 4 decimal places if it's possible. And then we can look clearly at all the decimals. Okay, so let's work this out. I'm doing the same. Okay. What do you think? Could we say that the left-hand side equals the right-hand side? What do you think, matrix? Is 0.3599? Yes, I agree. I think in this case, it's reasonable of us to conclude that 0.3599 is very, 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 very close to 0.36. Okay, perfect. So now we would say, are they independent of gender? So now we must make a conclusion. Therefore, the probability of being female and passing is indeed the same as the probability of being female times the probability of passing. Therefore, passing the exam is independent of gender. Okay, and it would be important for us to make that conclusion. Okay, so here we've already calculated this value, so I don't know if they'd give us a mark for that again. I'm sure they would give us a mark for working this out, getting that answer. Okay, maybe there would just be 1 mark here and there would be another mark for that, because you don't have to use female and pass. Okay.